Hello, in this tutorial, we are interested in finding the inverse of a 3 by 3 matrix. We are to find the inverse of this 3 by 3 matrix. So to do that, let's first run through the background of the ways of determining the inverse of a square matrix. We say inverse, given a matrix such as this, its inverse will be equals to 1 divided by its determinant multiplied by its adjoint. In one of our previous videos, we've discussed determinant of a matrix. Then, talking about adjoints, for us to move to the point of adjoint, we must learn that each of these entries has its minor. Take for example entry A11, its minor will be obtained when you cross this and you cross this. When you cross this row and you cross this column, this is its minor. So its minor will be A22, A23, A32, A33. When you get the determinant of these, you then bring it back to this point. You do the same thing for all the entries, then multiply it by the cofactor, which is the sign, which is plus, minus, plus, minus, plus, minus, plus, minus, plus for a 3 by 3 matrix. Now that this is clear, let's look at the problem. We are to find the inverse of this matrix. So in doing so, the very first thing is we are to find the determinant. Recall that the inverse is A inverse is equals to 1 divided by the determinant of A multiplied by the adjoint of matrix A. So to get the determinant, that's determinant of A equals, for the first entry here, if we are using this, remember it follows the sign plus, minus, plus, minus, plus, minus, plus, minus, plus. So this 3 open bracket, its minor, that is when we close this row and we close this column, what we have left will be its minor. So which is 4 multiplied by -3, that's minus 12, minus 5 multiplied by 1, that's 5, close it. We do the same thing for this element here, which follows the sign minus. So minus 1, open bracket. If you close this row and you close this column, we have -2 and -3, which is going to give us 6, minus 1 multiplied by 1, which is 1, done. Then to the last one, plus 2, open bracket. When you close this row and you close this column, we have this. That will be minus 10, minus 4. Moving further, we'll say 3 open bracket minus 17 minus 1 multiplied by 5 plus 2 multiplied by minus 14. So this gives us minus 51 minus 5 minus 28. Altogether we have minus 84. So the determinant of A is minus 84. Now that we have this as minus 84, we need to then look for the adjoint of this. Great. So to look for its adjoint, we first need to find, for each of these elements, for easy access, let's take it this way: 3, 1, 2, minus 2, 4, 1, then to the other side, which is 1, 5, minus 3. So we are going to look for the determinant of the minor of each. Remember, for this 3, when you close this row and you close this column, you have 4 multiplied by minus 3, that's minus 12 minus 5. That gives you minus 17. Maybe I should use other color for this. The same thing when we do for 1, this 1, remember it carries negative sign, but we are going there. Let's first do this. Close this and close this. You have this, that's 6 minus 1, which is equals to 5. For these 2, we close this row, we close this column. That will give us minus 10 minus 4, which is minus 14. For this one, these 2 here, close this column, close this row. We have 1 multiplied by minus 3 minus 2 multiplied by 5. That will be minus 3 minus 10, which is going to give us minus 13. 4, we close this column, we close this row. So we have 3 multiplied by minus 3, that's minus 9, minus 2 multiplied by 1, that's minus 2, which gives us minus 11. For the 1 here, close this column, close this row. That will be 5 multiplied by 3, 15, minus 1. So that will be 15 minus 1, gives us 14. We do the same thing here. Close this row, close this column. We have 1 minus 8. That gives us minus 7. For 5, close this and close this. We close this and we close this. That's 3 multiplied by 1. 3 minus 2 multiplied by minus 2, that's minus 4. So 3 minus minus 4, that will be 3 plus 4, which is equals to 7. And we do the same thing for the last one here. Close this column, close this row. 3 multiplied by 4, that's 12, minus 1 multiplied by minus 2, that gives us minus 2. So 12 minus minus 2, that's 12 plus 2, that's 14. Now that we know this, so if we try to bring in this, it becomes fixing each of these back to where they belong. Minus 17, 5, minus 14, minus 13, minus 11, 14, minus 7, 7, 14. So this that we have gotten, now to now get the real one, we have to multiply it by the cofactor sign. You know the sign: plus, minus, plus, minus, plus, minus, plus, minus, plus. So if we multiply each of the elements here, then we'll get it to be minus 17, minus 15, minus 5, that's minus 17, minus 5, then this is still minus 14, minus multiplied by minus 13, that's 13, minus 11, minus 14, plus multiply by this, that will be minus 7 plus 14. So now that we've gotten this, we will then need to transpose this. We have to transpose this new matrix. That will give us the adjoint. So the adjoint is adjoint of A equals, we have to transpose this. So transposing means changing the row to column. So it becomes minus 17 minus 5 minus 14, then 13 minus 11 minus 14, the third part, minus 7 minus 7 14. Now that this has been done, so we've gotten the adjoint. Remember, we have gotten the determinant of this matrix A to be minus 84. So following the formula that says A inverse equals 1 divided by the determinant of A multiplied by the adjoint of A. So the A inverse then becomes 1 divided by negative 84, then minus 17, 13, minus 7, minus 5, minus 11, minus 7, minus 14, minus 14, 14. So this is the inverse of this matrix. If we want to express it, the A inverse, if we want to express this fully now, we can then say the A inverse, let me clean somewhere here. The A inverse can totally be seen as you multiply that scalar value 1 over negative 84 by all the entries in the A inverse. That's if we need to simplify it, which is often expected of us. So the A inverse will now become, multiply this by each of these, minus times minus plus, that will be 17 over 84. Do the same thing here, that will be minus 13 over 84, that will be 7 over 84. Do the same thing here, that will be 5 over 84. Multiply this, 11 over 84, 7 over 84, and the last part, 14 over 84, 14 over 84, then minus 14 over 84. So this is the inverse of the matrix above here. So if you enjoyed this, don't forget to click on the like button and as well subscribe to this channel for more educative videos like this. Thank you.